In today's lesson, we are going to talk about this question from SMO2021 Open section. This is something to do with binomial theorem. Let S be the summation of 100 choose 4k where k run from 0 to 25 minus 2 to the power of 98. As you can see, this can be a big number. You are asked to find the floor of absolute value of S over 2 to the power of 48. You may try to consider the expansion of 1 plus x to the power of 100. Have a good try before you look at the answer.
Pause the video now if you wish to solve it. Keep watching the video once ready.
So, as I mentioned just now, we will consider 1 plus x to the power of 100. As you know from binomial theorem, this is summation 100 choose r, x to the power of r, where r equals to 0 to 100. It is well-known result that summation of 100 choose r from r equals to 0 to 100 is equal to 2 to the power of 100. And we can get this by letting x equals to 1. If x equals to 1, the left-hand side is 2 to the power of 100, and the right-hand side will be the summation r equals to 0 to 100 choose r. X is equal to 1, therefore 1 to the power of r is always equal to 1. This is a well-known result that we have from binomial theorem. Next, we'll consider x equals to a negative 1. If x equals to negative 1, the left-hand side will be equals to 0. And for the right-hand side, it is the summation r equals to 0 to 100 choose r, and this will be a negative 1 to the power of r. Then for this itself, we can separate into two cases because negative 1 to the power of r will be equal to 1 if r is even, and negative 1 to the power of r is equal to negative 1 if r is odd. We can separate into 100 to r from r equals to 0 to 50, and the other one is 100 to r minus 1 where r equals to 1 to 50. We know that when it is of even number, this is positive, and when it is of odd number, this is negative, so it will be equals to this expression. Now back to the previous one, the summation of this actually also can be written as 100 choose 2r, r equals to 0 to 50, and 100 choose 2r minus 1, r equals to 1 to 50. But for the previous case, we just simply add it together. You can treat it as a plus b equals to this value, a minus b equals to this value. Therefore, if you add these two equations together, this will be 2 to the power 100 plus 0, and this will be a double of 100 choose 2r, r equals to 0 to 50, and this will be cancelled off. And this will mean that the summation 100 to r equals to 0 to 50 is equals to 2 to the power of 99. This is another well-known result from Pascal triangle. So from x equals to 1, we have this result. X equals to negative 1, we have this result. One is 100 choose r, and the other one is 100 choose 2r. How are we going to obtain 100 choose 4r or 4k? So we may get that by considering another two value of x. That is, x equals to I and x equals to negative I. Okay, so consider x equals to I. 1 plus x will be 1 plus I, then to the power of 100. Now this itself is equal to 1 plus I square to the power of 50. And 1 plus I square is equal to 1 plus 2i plus I square. And we know that I square equals to negative 1. So this will be cancelled off. And we left with 2i to the power of 50. 2i to the power of 50 will be equal to 2 power 50, I power 50. And we know that this is negative 2, 50. On the other hand, when x equals to negative I, 1 minus I to the power of 100, using the similar argument, 1 minus I square to the power of 50 equals to 1 minus 2i plus I square to the power of 50. Again, 1 plus I square we cancel off. Negative 2i to the power of 50 again, it will be just exactly the same. 250, I 50. It is negative 2 to the power of 50 again. Let me write these two results over there and erase this part to save some space. If you enjoyed this video, please like, comment, and subscribe. So far we have these 4 results, and we are going to consider the last two. As you know that 1 plus x to the power of 100 equals to summation 100 choose r, x to the power r, r equals to 0 to 100. Now, so if x equals to I, we already know that 1 plus I to the power of 100 equals to negative 2 to the power of 50. So we need to sub I inside here. 100 choose 0. Let me just write this out first. Let me just write it out. 100 choose r for all r from 0 to 100. When r equals to 0, I to the power of 0 is 1. When r equals to 1, I to the power of 1 is equals to I. When r equals to 2, I to the power of 2 is negative 1. So it's negative 1. When r equals to 3, I to the power of 3 is negative I. Negative I. And when I equals to 4, it will repeat again. 1. 5, it will be I, then negative 1, and negative I. So it will be 1, I, negative 1, negative I. 1, I, negative 1, negative I, and so on and so forth until the last one is plus 1. So this is what happened for x equals to I. Next, it is quite similar, but now x equals to negative I. We know that when x equals to negative I, 1 minus I to the power of 100 equals to negative 2 to the power of 50 again, exactly the same. You also have 100 choose 0, 100 choose 1, 100 choose 2, 100 choose 3, all the same thing until 100 choose 100. Okay, so what's the difference from the previous one is I and now is negative I. For the even power, the value was still the same, but for the odd power, it will change by a sign. So for example, this is power 0, it's exactly the same. Then this is power 1, it will be a negative of whatever you have. This is power 2, it will be exactly the same. And this is negative 3, it will be the negative sign of the previous value. And it will continue until the last one, it will be the same. When we add these two together, then we will see that if it's 100 choose 2r, they will be double because you add up together. But if it's 100 choose an odd number, it will disappear. This will disappear. So when add up together, it will be 2 times negative 250. And it will be a double of what we have here. That is the summation 100 choose 2r, where r equals 0 to 50. But when r equals to 0 is positive, when r equals to odd number, in this case r equals to 1, it will be a negative value. So this should be a negative 1 to the power of r. And after we cancel the 2, this is negative 2 to the power of 50 equals to summation 100 choose 2r, negative 1 to the power of r, r equals to 0 to 50. Again, I will write this here to get some space. We are almost done by looking at this equation. By looking at this result, negative 2 to the power of 50 equals to the summation 100 choose 2r, negative 1 to the power of r, r equals to 0 to 50. We are using the similar method when we get this result. So what we do here is we will separate these r to two cases. One is 2k and the other is 2k minus 1. When r equals 2k, even number, negative 1 to the power of 2k will be a positive 1. And negative 1 to the power of even number will be a negative 1. So it will be equals to summation 100. When r equals 2k, that this is a 4k. And this is a positive value when k equals 0 to 25. And the other one is summation 104k minus 2. K equals to 1 until 25. Okay, and this is a negative. So how do you get the final answer? Now we do exactly the same thing from previous case. So this is summation 2r. When r equals 0 to 50, we can actually write as the summation 104k from k equals 0 to 25 plus the summation 104k minus 2, k equals 1 to 25 equals to 2 to the power of 99. Again, it is a minus b equals to this value, a plus b equals to this value. When we add it together, then this will be 299 minus 250. Okay, this will cancel off and this will be a double. Since it's double, so I divide by 2. Summation 100 choose 4k, k equals to 0 to 25. In order to get this, we have this part already. Minus 2 to the power of 98 is actually come from here. So this is 2 to the power of 48 minus 2 to the power of 49. This will mean that the s will equal to negative 2 to the power of 49. And since s equals to negative 2 to the power of 49, with the modulus, s over 2 to the power of 48 will be exactly equals to 2. With the floor function, it still remains as 2. So therefore, the answer for this question is equals to 2. So by using the binomial theorem on 1 plus x to the power of 100, by substituting x equals to 1, negative 1, I, and negative I, we'll get this kind of result. You may try to think of how to get summation of 3n choose 3k, where k runs from 0 to n. Please write your answer in the comment. That's all for today's lesson. I'll see you again next time. Bye bye.